Assalamualaikum and hi to the examiner. Today I will be introduced the X-ray machine and explain the basic concept behind it used in artifact analysis. An X-ray machine is a device that uses electromagnetic radiation to produce image of the internal structure of an object. In archaeology and museum studies, X-ray technology allows researchers to examine the valuable artifacts without damaging them. This makes it very useful tool for preserving historical objects. The scientific principle behind X-ray imaging is based on the production of penetration X-ray. And X-ray are generated when high-speed electrons collide the metal target inside the machine. This ray then pass through the object being examined. Since different materials absorb X-ray at a different rates, denser material absorb more radiation and appear lighter on the image, while less dense material appear darker. This difference enables scientists to observe hidden structure and identify the internal features. And the significance of X-ray technology lies in non-destructive nature. It helps archaeologists and historians uncover hidden details, detect previous repair, and study ancient manufacturing techniques without harming the artifacts.
Hi everyone, my name is PHY380 and today I will presenting on a detailed exploration of the instrumentation, hardware components, and the scientific working mechanism that allow an X-ray machine to analyze ancient artifacts. Let us examine the core instruments inside an X-ray tube. The entire process relies on converting electrical energy into kinetic energy and finally into electromagnetic radiation. This begins at the cathode, which houses the tungsten filaments. When we apply an electrical current, this filament heats up and releases cloud of electrons through a process known as thermionic emission. Directly opposite to this is the anode, which acts as our target material, usually made of heavy tungsten due to its high melting point. To make the electron move a high voltage power supply creates a massive potential difference between the cathode and anode. This accelerates the electron across the vacuum tube at incredible speeds. When these high-speed electrons suddenly crash into the tungsten target, they decelerate rapidly, generating X-ray photons. Before these X-ray leave the machine, they pass through the filter to block dangerous low-energy rays and collimators to shape the beam perfectly toward our historical artifact. Now, let's discuss the physics of how these beams penetrate fragile historical materials. Because X-ray possess very short wavelength and high frequency, they have the unique ability to pass directly through solid matter. However, as the X-ray beam travels through an artifact, it experiences something called differential absorption or attenuation. What does this mean? This means the amount of X-ray that can pass through depends entirely on the density of the atomic numbers and the material. For example, if an ancient state contains hidden metal pins or dense clay inside, those heavy elements will absorb almost all the X-ray. On the other hand, lighter organic materials like wood, textiles, or hollow cavities will allow the X-ray to pass straight through with very little resistance. These most things about this mechanism from an archaeological standpoint is that is complete non-destructive. We can peer deep into the internal matrix of a highly fragile thousands of years old object without scratching, opening, or damaging its delicate physical structure in any way. Finally, how do we capture this data and transform it into visual image? After the X-ray beam penetrates and exits the artifact, the remaining radiation hits a highly sensitive digital detector array. This detector measures the intensity of the escaping rays and translates them into digital error. We can process this data in two distinct ways, depending on our objective. The first method is a standard 2D radiograph. This produces a flat, high-contrast internal shadow graph where dense areas show up as bright white and less dense or hollow areas show up as dark gray or black. The second more advanced method is 3D computed tomography or a CT scan. In this setup, either the X-ray tube or the artifact rotates off a full 360 degrees. The machine takes thousands of individual 2D cross-sectional images from every single angle. Advanced computer software then process these slices and reconstruct them into a highly detailed, interactive 3D digital model. This allows researchers to virtually slice open an artifact on a computer screen. So that's all for me. Thank you.
Next, I will explain some real examples of how X-ray are used in historical artifacts. The first example is ancient mummies. X-ray allow researchers to examine mummies without unwrapping them. This means the mummy can remain preserved, while scientists can study the teeth, bones, estimate the age, identify the disease, and even investigate the cause of death. They can also detect the internal structure and any burial objects hidden inside the mummy. The second example is old statues. X-ray helps reveal internal cracks, weak areas, and hidden damage that cannot be seen from the outside. Conservators can also identify the previous repairs and hidden components inside the statue. This information helps them to plan restoration safely while keeping the original artifact undamaged. Third example is historical paintings. X-rays are very useful because they can reveal the hidden sketches beneath the paint layers. This allows experts to see artist's original drawing or any changes made during the painting process. In addition, X-rays can detect hidden signatures and previous restoration work that may not be visible to the naked eye. This helps experts verify the authenticity of the artwork and preserve it properly without causing any damage. Overall, X-ray technology is a non-destructive method that helps researchers and conservators study and preserve valuable historical artifacts while keeping them in their original condition.
So today I will discuss about the potential benefit of using X-ray imaging for artifact analysis. Firstly, X-ray imaging is completely non-destructive. This means researchers can examine an artifact without cutting, drilling, or physically altering it. This is especially important because many historical artifacts are rare, fragile, and cannot be replaced. By using X-ray, valuable information can be collected while preserving the artifact in its original condition. So, secondly, X-ray imaging provides high accuracy. It allows researchers to see internal structures that are not visible from the surface, where hidden cracks, previous repair, and different material composition can be identified. This helps experts understand how an artifact was made and whether it has undergone restoration or been modified over time. So the last point is, X-ray imaging helps to preserve historical integrity. Since the artifact remains untouched, its historical and archaeological value is maintained. In addition, multiple scans can be carried out over time to monitor any changes or deterioration without causing damage. Now let's take a look at some of the challenges to analysis artifacts. The first challenge is radiation risk, where the X-ray equipment produce ionization radiation, which can be harmful to operator if proper precautions are not taken. Therefore, facility requires protective shielding, monitoring equipment, and trained personnel to minimize the radiation exposure. So the second challenge is a high maintenance cost. The advanced equipment such as X-ray system, digital radiography system, and the CT scanners are expensive to purchase and maintain. So specialized software and skilled technicians are also needed to accurately analyze and interpret the imaging results. So the last point is handling fragile artifacts. Many historical objects are extremely delicate and may be damaged during transportation or positioning during scanning. To prevent this, extra care, customized supports, and controlled environmental conditions are necessary when scanning ancient artifacts.
Okay, so now I will present about future development. Development of portable X-ray scanners for easier fieldwork and artifact examination. And secondly, integration of artificial intelligence, or we know as AI, to improve image analysis and defect detection. Next, higher image resolution for more detailed international visualization of artifact, and other than that, reduction of radiation exposure through safety and more efficient X-ray system. Next, use of digital and cloud-based to technology fit better image storage, sharings, and also analysis. And lastly, it also can improve automation to speed up scanning process and increase the accuracy. Okay, so for the conclusion, X-ray instrumentation is an important non-destructive technology used to study and preserve historical artifacts. It also allows to researchers to examine the internal structure and condition without causing any physical damage. This technology helps uncover hidden details, detect the deterioration, and provide valuable information about an artifact history and construction. Although there are challenges such as radiation safety concern and high equipment costs, and the benefit of X-ray analysis, it also makes it a highly effective tool in cultural heritage preservation. And for the future investment in technology, X-ray instrumentation will continue to play a significant role in protecting and understanding historical artifacts for future generations. That's all from us. Thank you.